All right, let's dive into something we all deal with but maybe don't fully understand: antibiotics and vaccines. They're two of the most powerful tools in modern medicine, for sure, but they do totally different jobs, and knowing that difference is key.
So let's start with a big question. Think about it. What's better, fighting off an intruder who's already kicked down your door, or having a security system so good they can't even get on your lawn? That, right there, is the heart of what we're talking about today.
I want you to imagine your body as this incredible battlefield. There's a constant war going on inside you against these tiny, microscopic invaders. And in our corner, we've got two brilliant weapons: antibiotics and vaccines. But you've got to use the right weapon for the right enemy.
So, first things first, let's get to know the players in this fight. Who exactly are we up against in this battle inside you?
Our two main foes are bacteria and viruses. Now, they're both germs, they're both tiny, and they can both make you really sick. But that's kind of where the similarities end. Biologically, they are worlds apart, which means you absolutely cannot fight them the same way.
All right, let's grab our first weapon from the medical toolkit, the antibiotic. Think of this as your emergency response team, the frontline soldiers you call in when a very specific enemy has already breached the gates.
And here's what makes them so special. Antibiotics are like highly trained assassins. They are programmed to hunt down and destroy one thing and one thing only: bacteria. They target parts of the bacterial cell that our own human cells don't have, so they can wipe out the invaders without causing a bunch of collateral damage.
And you really can't overstate their impact. I mean, look at this list. Nasty bacterial infections like pneumonia or tetanus. Before antibiotics, these were often a death sentence. Antibiotics completely changed the game.
So how do they actually work? Well, it's like a special forces raid. Some antibiotics just blast right through the bacteria's outer wall. Others are more subtle. They get inside and jam up the reproductive machinery so the bacteria can't multiply. And some just shut down their internal power grid. Either way, the invasion grinds to a halt.
And you know, the story of how we got them is amazing. It was a total accident. Back in 1928, a scientist named Alexander Fleming gets back from vacation and finds this weird mold growing on a plate of bacteria he left out. But here's the crazy part. Everywhere around the mold, the bacteria were dead. He realized this fungus was making its own weapon, a substance he called penicillin. And just like that, the age of antibiotics began.
But there was a catch. This incredible new weapon had an unintended consequence. As soon as we started fighting back, well, the enemy started to adapt.
And here's the huge problem we're facing today. Bacteria reproduce so fast they can also evolve incredibly quickly. So when they're exposed to an antibiotic, a few of them might have a random mutation that, just by chance, helps them survive the attack. We call this antibiotic resistance, and it is a massive global threat. It means our best weapons might stop working when we need them most.
You know, Fleming himself warned this would happen. He said if you don't take your full course of antibiotics, you might kill off all the weak bacteria, but you leave the strongest, toughest ones behind. And what do those survivors do? They multiply, creating a whole new army of what we now call superbugs that our old weapons just can't touch.
So if antibiotics are our attack force, what's our other option? Well, this brings us to weapon number 2, vaccines. And if antibiotics are the soldiers, vaccines are the intelligence agency. They use a completely different strategy. This right here, this is the single most important difference to remember. Antibiotics treat you when you're already sick with a bacterial infection. Vaccines prevent you from getting sick in the first place, usually from a virus. One is reactive, the other is proactive.
See, a vaccine doesn't actually kill anything directly. Instead, it's like a training manual for your body's own personal army, your immune system. It teaches your body how to spot and defeat specific enemies, like the viruses that cause polio or the flu, before you ever encounter them in the wild.
So how does this training actually work? It's pretty brilliant. The vaccine introduces a safe, harmless version of the enemy, like a dead virus or just a piece of one. Your body's soldiers, your white blood cells, see this imposter and learn how to build the perfect custom weapons, called antibodies, to destroy it. Then, your immune system creates a memory of that fight plan. So if the real dangerous virus ever shows up, your body doesn't panic. It just says, oh, I've seen this guy before, and cranks out those antibodies super fast to wipe it out.
And the origin of this idea is just wild. Way back in the 1700s, a doctor named Edward Jenner noticed something odd.
Milkmaids, who often got a mild disease from cows called cowpox, almost never got the deadly disease smallpox. He had a radical idea. What if getting the mild disease was training their bodies to fight off the deadly one? He actually tested it, it worked, and the entire concept of vaccination was born.
So, let's bring this all home. Think of this as your personal health toolkit. You've got two incredibly powerful tools at your disposal, but just like any toolkit, they only work if you use them for the right job.
Because taking an antibiotic for a virus, like the common cold or the flu, is completely pointless. It's like sending a SWAT team to deal with a leaky faucet. It's the wrong tool for the job, it won't work, and even worse, it contributes to that huge problem of antibiotic resistance, making our best weapons weaker for everyone.
So let's boil it all down. Here's your ultimate cheat sheet. Antibiotics, thanks to Fleming, treat bacterial infections by killing the invaders directly. Vaccines, pioneered by Jenner, prevent infections, mainly viral ones, by training your body to fight. Different targets, different timing, different methods entirely. And that leaves us with a pretty big question, doesn't it? We have these incredible scientific weapons in our toolkit, but as bacteria keep evolving and new viruses keep emerging, the race is on. Knowing how these tools work and using them wisely isn't just about your own personal health. It's about making sure these amazing discoveries can protect all of us for generations to come.